Hello students, good afternoon. I am Dr. Smrutirekha and I welcome you all to Etuson, Education for Better Tomorrow. Etuson is a digital learning platform which deals with Odia and English medium students. Have you downloaded the Etuson app? Please download it and register so that you can avail all the facilities in your fingertips. Now coming to today's topic. Hope you have watched my previous video where I have given the concept of rational number. Today we are going to discuss about properties of rational number. In my previous video I have performed one activity which demonstrates how the different types of numbers are required to solve different kinds of situation. Today we are going to see how the different kinds of numbers are required in case of linear equation. While solving linear equation, how you need different kind of number. For example, suppose you have x plus 2 is equal to 5. Then what is the solution to this? So x is equal to 5 minus 2, that is equal to 3. So what kind of number is 3 here? So 3 is natural number. Correct or not? Yes. Now suppose you have another kind of equation where x plus 5 is equal to 5. So in that case, x will be equal to 5 minus 5, that is 0. Now what kind of number is this 0? Is it a natural number? No, it's not natural number. So their whole number came into picture. Correct. Now suppose your linear equation is in this form. So suppose x plus 12 is equal to 5. It implies what is your x value? X is equal to 5 minus 12, that is equal to minus 7. Now what kind of number is this minus 7? Is it natural number? Is it whole number? No. Then what it is? It is a kind of integer. And what kind of integer it is? It is negative integer. So in integer you have negative integer, you have 0 and positive integer. Now let us consider another kind of linear equation where 7x is equal to 5. So in this case, what will be the value of x? So x is equal to 5 by 7. Now what kind of number is 5 by 7? Is it a natural number or whole number or integer? No, this is a fraction or rational number. Now the number is said to be a rational number when it is expressed in form of p by q, where your q is not equal to 0 and p and q are co-prime. P and q are co-prime. Co-prime means p and q doesn't have any common factor other than 1. Now we can observe this p by q form. Just observe this form p by q. All the natural numbers, whole numbers, and integers can be expressed in terms of p by q. Even if the denominator is 1, maybe the denominator will be 1, but it can be expressed in terms of p by q. So rational number includes all the integers, whole number and natural number. So now we have understood how the different numbers are used to get the solution of a linear equation. Correct? So now let us go to the topic, which is properties of rational numbers. So basically, we will be dealing with closure property, commutative property and associative property. So I don't think we will be able to complete all the property today. So we will try to complete at least closure property in today's class, and rest two properties we will be discussing in the coming session. Okay, so let us go to our first property, that is closure property. Okay, so what do you mean by closure property? So closure property basically states that if in two operands an operation is applied in which both the operands belong to the same set, then the value after that operation, the result should belong to the same set only in which the operands belong. What do you mean by such a big statement? So it will be clear if you write it in form of some notation. It means that if in two operands an operation is applied, so suppose the two operands are A and B. Which operation you are going to perform? You are going to perform the operation called addition. So you will write A plus B, where A and B both operands belong to same set. So suppose you consider A and B belongs to your, both A and B belongs to your what? Natural number. So what does the statement indicates? If A and B belongs to natural number, the operation which you are going to perform, the resultant of it, suppose the resultant is C now. This C should be a natural number. If this C is not found to be a natural number, in that case, we cannot say that the particular operation is closed or satisfying the closure property. So this particular uh, thing or this particular uh, logic can be applied for all kind of operation. Correct? So now let us perform all kinds of operation for different kinds of number. Okay? So first we will consider for the natural number. So we'll be performing the operations addition, subtraction, multiplication and division. So let us consider natural number. So I have suppose considered natural number 5 and 7. So 5 plus 7, addition 5 plus 7, the answer is 12. What kind of number is this? 12. So 12 is a natural number. So we can say that natural numbers, so we can say that natural number are closed under addition. Correct? So this is the way you should try. Now let us perform the subtraction operation. 5 minus 7. What's the value? That is minus 2. Is minus 2 a natural number? No, it is not. So you will write, so natural number are not closed under subtraction. Correct? Now considering the same two numbers, suppose I will write 5 into 7. What's the value? 35. Is 35 a natural number? Yeah, it is a natural number. So you will say, so in case of natural numbers are closed under multiplication. Same is the case of division. Let us perform the division operation. So 5 divided by 7, that becomes 5 by 7. Now what kind of number is 5 by 7? Is it a natural number? No, it's not a natural number. What kind of number it is? It's a rational number. It's a fraction. So we'll write natural numbers are not closed under division. Correct? So now let us form the different operation to check whether the closure property is satisfied for whole number or not. Okay. So I will take a number. So whole number means natural number plus 0. So suppose consider 1 is 0. So one number is 0 plus 6. Value is 6. 6 is a whole number. So it is natural number, the whole numbers are closed under addition. Whole numbers are closed under addition. Suppose I'll write 0 minus 6. What's the answer? Minus 6. Is minus 6 a whole number? Yes. No, it is not a whole number. Correct. Minus 6 is integer, no? Yeah. So, don't get confused, okay? So, 0 minus 6 is equal to minus 6. It is not a whole number. So, you will write whole numbers are not closed under subtraction. Correct? Now suppose 0 into 6. What's the value? It's 0. 0 is a whole number, right? So, whole numbers are closed under multiplication. Now consider division. 0 divided by 6 is equal to 0, undoubtedly. But just check the vice versa. Suppose you write 6 divided by 0. What is the answer? The answer is undefined. So, you cannot say that whole numbers are closed under division. So, what you have to write? They are not closed under division. Correct? Now, let us go to integers. So, integers include your negative integers, 0, and positive integers. So, now let us consider that your numbers are, suppose one is minus 5, another one is 7. So, suppose minus 5 plus 7. How much is the value? It is 2. 2 is a integer, positive integer. So, closed under, integers are closed under addition. Correct? Suppose now I'll write minus 5, minus 7. What's the answer? Minus 12. Is minus 12 an integer? Yeah, it is a negative integer. So, integers are closed under subtraction. Okay? Now, suppose I will take this operation minus 5 into 7 or minus 5 into 0. So, the answer will be what? Minus 35. If you multiply with 0, that becomes 0. Is minus 35 a integer? Yes, it is one integer. It is negative integer. So, In case of integer, you have, so integers are closed under multiplication. Now consider the division operation. Now suppose I will write -5 divided by 0. Okay. So here -5 one integer, 0 is another integer, but the answer is undefined. So integers are not closed under division. Correct? Now let us do the operation for our rational number. Okay. So first one, that is addition. So now let us take some rational number in P by Q form. So suppose you have 1 by 2 plus 2 by 3. So I'll take the LCM as 6. So you will get 3 here. So 3 plus 2 into 2, that is 4. So the answer is 7 by 6. Each 7 by 6 is rational number? Yes, it is rational number. So you can write for rational numbers are closed under addition. Correct. Now suppose I will take the same rational number 1 by 2 minus 2 by 3. Okay, so what you will get? So you will get 3, 2 into 2, it is 4 divided by 6. What's the answer? So it is minus 1 by 6. Now minus 1 by 6 is rational number, right? So in case of rational numbers are closed under subtraction. Now coming to multiplication. So same number I will take half into 2 by 3. What's the answer? That is 1 by 3. So 1 by 3 is also a rational number. So rational numbers are closed under multiplication. Under multiplication. Okay. Now consider division. So suppose I will take these two numbers first. Half divided by 2 by 3. So in this case half into 3 by 2. Answer becomes 1 by 2. But it's a rational number, no doubt. But if you do 1 by 2 divided by 0, what is the answer? It is undefined, right? So you have to say that rational numbers are not closed under division. So now I hope you have understood the closure property properly. Correct? And you could have found out the difference how in different kind of numbers the closure property is going to vary. Correct? So I think time is over. So we will discuss the rest two properties of rational number in the next class. So in the next class we are going to discuss about commutative property and associative property. So don't miss the class. Okay. Thank you so much for your patient hearing, and don't forget to download the app. So see you in the next class. Please solve some equation, some problems related to your closure property so that you can understand the concept in a better way. Thank you.